and we were looking at vectors. Let's see, so I might have a vector that starts at the point 1, comma 2, and ends over here. What would you call this point? What's a reasonable answer?
4, 5.
4, 5? Okay. And I want to write that vector, and I want to put it in standard form. What did I mean by write it in standard form? Standard form, typically we don't start at 1, comma 2, we start at the origin. We start at 0, 0. So this vector is going to look like so. If this vector used to start at 1, comma 2, and now I'm making it start at 0, comma 0, where does it end? Well, 3, comma 3. Why 3, comma 3? I have to move down 2. So if I can start at 5 and I move down 2, that puts me at 3. So I have to move down 2 and left 1. So that puts me at 3, comma 3. Why is it very handy to have a vector written in standard form where it starts at the origin? It's very easy to get the magnitude. So if I call this vector v, I might use this symbol for magnitude of vector v. And what does magnitude mean again? It means the length. So how long is that vector? Not 4. I use a distance formula. Well, I don't really need the distance formula. Square root of 18 sounds correct. I can simply use this triangle. This is 3, this is 3, so it's Pythagorean theorem. Distance formula is a fancy way to use the Pythagorean theorem, so you're right. That's square root of 9 plus 9, which is square root of 18. So the length of the vector is square root of 18. It also makes it quite easy for me to find the direction of this vector, to find that angle theta. How would I find that angle theta?
Just use sine, cosine.
I could use sine or cosine, but the one I'm going to use is tangent. Why would I use tangent? Because x and y are given. So I would use tangent theta is y over x, which is 3 over 3, which is 1. So in this case, theta is 45 degrees, or if you prefer, 5 or 4 radians. Notice what we just did. We took this vector, we moved it to standard form, and then we found the magnitude and the angle. That's exactly the same thing we did with something else. It's exactly the same as what? Instead of calling this the point 3, comma 3, I could also call this the point square root of 18, comma 45 degrees. So what did we do? We just changed it into polar form. Vectors are very commonly given both ways. You'll see vectors very commonly given in rectangular form. So we would say this is the vector 3, comma 3, which means it starts at the origin and ends at 3, comma 3. Quite often you will also see vectors given in polar form. They're given both ways. And that's a big reason why we want this vector to start at the origin. When we start at the origin, it's pretty easy to convert between rectangular form and polar form. Questions on that? All right, and then I think the next thing we started talking about just a little bit the other day is adding vectors. So if I had one vector like this, I'll call this the vector u, and another vector like that, call that the vector v. How do you add two vectors together? You could break it into its components. We haven't talked about that yet. But you could do it that way. That's not what we're going to do. Not yet, anyway. What else? Any other good ideas? I could find both their angles and put them in polar form and then add things in polar form. That would work. Again, that's too hard. All I'm going to do is I'm going to take this vector v, and instead of starting it at the origin, I'm going to have it start right here. So I'm going to take this vector v and I'm going to shift it over. So I take this vector v, I shift it over, I draw a vector that's parallel in the same length, and then what I'm left with, this vector here, is the vector u plus v. Now notice I could have done it the other way. I could have taken this vector u and had it start where v ends, which would have given me this, like so. And I end up with a special shape here. What's this shape called? That's called a parallelogram. Why is that a parallelogram? Because these two line segments are parallel, and those two line segments are parallel. That's called a parallelogram. What do you know about the angles in a parallelogram? They add up to 360. All right, so angles in a parallelogram. Add up to 360 degrees, and that'll be important for us here in just a minute. A square is a very special parallelogram, yes. A square is a special parallel. A rectangle is also a parallelogram. So a square is a special rectangle. A rectangle is a special parallelogram. So yes, a square is a parallelogram.
Okay.
All right, the other day, as I recall, we did problems 1 and 2.
Yes.
All right, so let's take a look at 3. Number 3 says, two forces of 255 newtons and 325 newtons act on an object. The angle between the forces is 64 degrees. Find the magnitude of the resultant and the angle it makes with the larger force. All right, so I'm going to draw myself a picture here. I'm going to put the larger force, if I want the angle it makes with the larger force, then I'm going to put the larger force on the x-axis. So my longer force is this one. That's 325 newtons. And then my smaller force is 255 newtons. And this makes an angle of 64 degrees. Well, that's not a very good picture. That doesn't look like 64 degrees. It looks more like 45, but oh well. That's okay. It says, find the magnitude of the resultant in the angle. What's resultant mean? Fancy word. It just means, it's like we add them up. Resultant means just add them together. So, if I were to add these two angles together, add these two vectors together, I would take this vector here and put it on the end, and it would go up this way, like so, and it would be 255 newtons, and then I would have my resultant. So what I'm looking for is I'm looking for the length of this vector, and I'm also looking for the angle of this vector.
How do you know which goes on which? Like, how do you know that 325 is on the x-axis?
What's that?
How do you know that 325 is on the x-axis?
Truth is, you can put either one on the x-axis. The reason I put this one on the x-axis is because I was looking ahead, and it said, find the angle it makes with the larger force. Whichever one it wants the angle with reference to, it's much easier to put that one on the x-axis. I could have drawn it the other way. It would work. I would get the same answer, but it's going to be easier in the long run. If it wants the larger force angle, then you put the larger force on the x-axis. All right, I'm also going to draw this vector here. This one would have length 325 newtons. All right, so any ideas? Any ideas on how to find either the angle or the length of the resultant vector?
Can you do the law of sines?
You're close. It's not the law of sines, it's the law of cosines. Because what I know is I know this side, I know this side, well, in fact, I know all the sides. If this is 64 up here, what's this angle over here?
64.
This one's also 64 degrees. So how about this angle?
Just add those two angles and subtract from 360. Go from 180.
All right, so I take these, all the angles have to add up to 360. So I add these two together, and you can either subtract from 180, that would work, or you subtract from 360 and divide by 2. Either one would work. So we can find that angle. So how much is that angle? 160? 16, 116. So this angle is 116, which means this angle is also 116. All right, so there's that important fact that we needed, that the angles add up to 360. Now, look what I have. If I use this triangle right here, this triangle, I'll draw it in a different color here, although colors aren't showing up very good today. This triangle, notice I have this side, and I have the angle between them, and I want to find that side. That's a law of cosines problem. So I'm going to call this, I don't know, what do you want to call this? Give me a letter. W. W.
So law of sines and cosines work on not. Oh yeah, never mind. That was stupid.
Right. The reason we had the law of sines and cosines is to work on triangles that are not right triangles.
Yeah.
That's correct. Law of sines and cosines work on right triangles too, but we want them for non-right triangles. All right. So we're going to have W squared equals 325 squared plus 255 squared minus 2 times 325 times 255 cosine of 116 degrees.
Are you solving for right triangles right now? Is that what?
I'm using this triangle. And the other triangle is exactly the same thing.
Yeah.
Correct.
Is this on our sheet, this formula, or did you memorize this?
The law of cosines?
Yeah.
You should memorize the law of cosines. It's almost the Pythagorean theorem. It's c squared equals a squared plus b squared.
Uh-huh.
And then you got to fix it, so it's a minus 2ab cosine c. So it's almost the Pythagorean theorem. It just got a little bit of fixture because you're not dealing with a right triangle.
So c squared plus a squared plus b squared minus...
C squared equals a squared plus b squared minus 2ab cosine of angle c. Not your law of cosine. All right, so anyway, I grabbed my calculator. 325 squared plus 255 squared minus 2 times 325 times 255 times cosine of 116 equals, and then I take the square root of that answer. I get that W, the length of our resultant vector, is 576 newtons, rounding to the nearest newton. I got 575.9. I'm going to call that 576.
What does Newton convert in to pounds or meters or something?
Newtons? What's newtons again?
Way to measure force.
It's a measurement of force. So it's, I think it's meters per second squared or something like that. Called newtons. If you're dealing in the non-metric system, they call it slugs. It's feet per second squared, I believe. All right, so there's the force, 576 newtons of force in that direction. And then we want to find the angle. How am I going to find this angle? I can't use tangent because I don't have a right triangle. Lou?
Hey, can you show me what
Sure.
Yeah, because I'm not getting what you're getting.
Can't get a... Okay, so putting my calculator into degrees mode, I now get the same answer you guys are getting. That's better. All right, so now we still have the question, how are we going to find this angle?
Can you just divide by 2?
Divide what by 2?
64.
I can't divide the 64 by 2. This certainly is not a bisector because we're pushing harder in this direction than we are in that direction. So this resultant is not exactly in the middle. It's more towards the 325 than it is the 255. I can't use tangent because I don't have a right triangle. If we don't have a right triangle, we either use law of sines or we use law of cosines. That's correct. Now that I have this angle and I have this side, I now have an angle in its opposite side. So now I can use law of sines. You're exactly right. Even though we rounded the answer, unfortunately we have to use a rounded answer. We don't have a choice. Sometimes you're stuck with that. You don't like it, but you live with it. All right, so we're going to have sine of this angle theta. Sine of theta divided by its opposite side is the 255 equals cosine of 116 degrees divided by this W that we just found, 493. So theta is, I take 255 times the cosine of 116 degrees, I divide that by 493, and then I do the...
Wait, why are you using cosine?
Is it sine?
Shouldn't it be sine?
Okay. I was getting very concerned.
I suppose if we're using the law of sines, we should use sine. Yeah, I can live with that. All right, so that's better. Then I have to divide by 493, and then I have to do the sine inverse. I get 27.7 degrees. Questions on that one?
And now for this one, there's only one angle, right? Because it's a quadrant.
Correct. And notice that we already have, within our triangle, we already have one angle that's obtuse.
Okay.
You can't have two obtuse angles in a triangle. So since we have one angle that's already obtuse, there's only one possible correct answer.
So we'll get to find the other angle there too?
It didn't ask us to, but we could.
Okay.
It would be 180 minus 116 minus 27.7.
Then you just do 64 minus 7.7.
I could do that too. 64 minus 27.7 would give me this angle, which is exactly the same as that angle because you've got alternating interior angles from your vast knowledge of geometry. Yes. But it didn't ask us to find it, but we could easily. All right, what else do we have? All right, it says, the magnitudes of vectors u and v and the angle between them are given. Find the sum of u and v. All right, again, I think it would be helpful to draw a picture. How would you draw your picture?
Put 12 on the x-axis.
Put one of them on the x-axis. It doesn't really matter which one. So you want 12 here. And then 10 would be like in that direction. And the angle is 36 degrees. And what do we want? The resultant. So again, I would draw my 10 again over here and complete the parallelogram. I want that length right there. That would be the magnitude. And I want to know this angle right here.
You know it would be quadrant 1.
What's that?
You know it would be quadrant 1.
Well, it's in quadrant 1 in this case because my angle is 36 degrees. If they told me my angle was 120 degrees, then I would be drawing my second vector this way. And my answer might be in quadrant 1, it might be in quadrant 2 in that case. Usually the angle between two vectors is small, so usually you're going to end up with something in quadrant 1. Makes your life a lot easier. All right, what do you do? The law of cosines? I think so. Because if this angle here is 36 degrees, this angle over here is also 36 degrees. So again, I think we can find this angle in between where U and V live. So that angle would have to be 360 minus 36 minus 36. Divide by 2, I get 144. So that angle in between is 144 degrees.
Did you just add up?
I did. Yep, I did 360 minus 36 minus 36, and then I took the whole answer and divided it by 2. Yep.
Couldn't you just take 180, subtract 180?
I could do 180 minus 36, and that would give me the same answer, yeah. Exactly the same answer. And so I think you're exactly right. I think once again this is a law of cosines problem. So to find this distance, I'm going to call that distance x. I would have x squared equals 12 squared plus 10 squared minus 2 times 12 times 10 cosine 144 degrees. And again, a lot of calculator work on these problems. 12 squared plus 10 squared minus 2 times 12 times 10 times cosine of 144. And then I take the square root of that answer. I got
20.9.
20.9. Good, I got the same thing. So let's call it, well, we'll call it 20.9, I guess. So there's the magnitude of the answer. The magnitude is 20.9. And then once again, how are we going to find the angle? I'm looking for this little, oh, we don't have to?
Yeah.
Well, it really wants the sum of U and V. So to describe the sum, I either have to give the length and the angle, or I would have to give its x-coordinate and its y-coordinate. So I think I would just go ahead and find the angle. I'm going to give my answer in polar form. I'm going to give the, I shouldn't have called this x, because x, anyway, too late, I called it x. All right, so we find the angle. Sine of theta divided by 10 is sine of 144 degrees over 20.9. So theta is 10 sine of 144 degrees divided by 20.9. Do the sine inverse, and I got 16.3 degrees. Questions on that? Lindsay? You got it? Okay. Other questions? All right, so this is similar, number 5, this is similar to the problem Grace asked in the homework that I said we haven't gotten to this yet. All right, so it says, a ship sails first north 80 degrees east for 120 knots. All right, so how do I draw north 180 degrees for 120 knots? Start at due north. Go 80 degrees from there. So it's only, we would normally call that 10 degrees. All right, so we're going this way for 120 knots. This angle right here is the 80 degree angle, which means this one inside is 10. We might need that in a minute. I'm not going to draw it yet, so things don't get too ugly maybe. All right, so the ship went that way for 120 knots. And then it turned and it went south 20 degrees west for 200 knots. So starting right here, what would south 20 degrees west look like? Here's due south.
20 degrees.
20 degrees to the left of that, because west is to the left. So the ship is now going this way for 200 knots. And this angle in here is 20 degrees. Then it wants to know, how far is the ship from its starting point? So I want to know this distance. I'm going to call it D for distance. And in what direction? I would probably do the direction from here, I would agree. So that's going to be south something, then towards the east, right? Because this is due south, this due east is towards the east of that. So we need to find this angle theta. So we would describe it as south, whatever that angle is, east. All right. Any ideas?
We could put some angles on it first.
We could put some angles on it. Okay. Give me some angles.
That was 10.
Which one's 10? This one?
Yep.
Okay. That one's 10 degrees. Anything else? All right, what if I were to draw a horizontal line right there? What's that? Then this, with this green one and this red one, that would be a 90-degree angle. I agree. What else could you tell me?
Wouldn't it be like 90 minus 20 minus 10?
It would be 90 minus 20 minus 10. Where'd you get the 10 from? This angle up here,
Yes.
that one would have to be 10. That's your alternating interior angles deal again. So you're absolutely right. This angle right here, inside this triangle, would be 90 minus 20 minus 10. What's 90 minus 20 minus 10? That's 60 degrees.
And you could find the obtuse angle too, right? Since you have those other two angles though, did you get that obtuse angle?
I probably could figure out these angles some way. I'm not too worried about them yet, though, because what I'm looking at is I now know this side is 120. I know this side is 200. I know this angle is 60. I think I can find that side. How can I find that side? It's the law of cosines again, isn't it? All right. D squared is 120 squared plus 200 squared minus 2 times 120 times 200. Cosine 60. Again, grabbing my calculator, pushing a whole bunch of buttons. 120 squared plus 200 squared minus 2 times 120 times 200 times cosine of 60 degrees. Cosine of 60 degrees is a half. Because I just typed in cosine of 60 degrees, I guess. So D is, taking the square root of all that answer, I get D is 280. Exactly. Works out perfectly. It's a nice number. Didn't have to round off. All right, so D is 280. All right. I think so. Michael?
Good question. Are there any more variations within the law of cosine or simply one?
Well, they're all the same. If I have c squared here, then I have angle c here.
Okay.
What if I have a squared here?
I'll just be a.
Then I'm going to have b's and c's over here,
And then 2c, b, and then
cosine
cosine.
a.
Okay.
So once you know one of them, you really just move the letters around and you know all of them. Yep. All right, now what?
How did you get to read?
I typed all this in and then I did the square root.
Well, I did that too, and I'm not getting that.
All right.
You got 174.
I got 174.
Me too.
Oh, there's a good reason for that.
Do you have ratings again?
No. Instead of a minus right there, I typed in a plus. But 280 came out, I didn't have to round it off. I like that number better.
Sorry.
You want to be right, I suppose. All right. D is 174. I'm having many calculator issues today. 174. All right, so now we have the right number. That's a good thing. Angle. How are we going to find this angle over here? Well, how about we find this angle right here in the triangle? If I knew this angle inside the triangle, how could I find this little angle down here?
You just
Subtract
subtract it from
it from,
90, right?
I don't think I would subtract it from 90 because I'm not going to the axis, I'm going up to the green line. Well, this whole thing would be 180, right? So if I find this angle, I could do 180 minus the 80 minus whatever I get for an answer here, and that would give me the little angle. So again, I think that's what we have to do, and I think that's a law of sines problem. So I'll call this angle alpha, I guess. Sine of alpha over its opposite, which is 200, equals sine of 60 divided by the 174 that we just figured out. So as you can see, when you're adding vectors together, you use the law of cosines and you use the law of sines, and you use them for almost every problem over and over and over again. All right, let's see if I can do this one right. 200 sine 60 divided by 174. Then I do the sine inverse. I get alpha is 84.5 degrees. So the angle I want, I would take 180 minus 80 minus 84.5. I get 15.5. So my answer would be the ship has traveled 174 knots from where it started, and it's at an angle of south 15.5 degrees east.
Can you explain the again, sorry?
The fi-
You just subtracted from 180.
I took 180
Okay.
minus this answer I just found, 84.5, minus that 80, because I was looking at this total thing here
Okay.
would be 180 degrees. So I subtracted off the 80, subtracted off the alpha that I just found. That leaves me with what's left.
Do you want us to round the, like, would that make a difference if we protected it, which is 84?
If you had just rounded this to 84, then you'd have a slightly different answer there. Typically, if you're doing your homework on MyLab is very specific. It will tell you exactly how to round. On a test, I will usually tell you how to round. I might say round to 1 decimal place. Okay. All right, so we have a couple more problems to do on this. These are short. We'll finish this off on Friday, and then we'll move on to section 8.6.